Hi, this is Alex from devstories.eu. Snowflake and Snowpark Python, episode 6 of 17. You write 10 complex data frame operations in a row, but the system does not run 10 separate queries. Instead, it delays execution and builds one perfectly optimized SQL statement under the hood. Today we are talking about transforming data frames. When you transform a data frame, you are setting up a recipe for how to shape your data. To build this recipe, you need a reliable way to reference the underlying data columns. You do this using a function named call. You pass the name of a column as a string into this function, and it returns a column object. You then use this object inside other methods to build expressions, like checking if a column value equals a specific number or text string. Let us look at a concrete scenario. You have two data frames. One holds customer profiles and the other holds transaction records. You want to identify high-value users and connect them to their recent purchases. If you wrote this in raw SQL, you might end up with a large nested query that forces you to read the logic from the inside out. With data frames, you use method chaining to write the logic from top to bottom. First, you take your customer data frame and call the filter method. Inside that filter, you use the call function to point to the spending tier column and specify that it must equal your top tier. Right after that filter, you chain a select method. You use the call function again to state that you only want to keep the customer ID and the email address. Every transformation returns a new data frame, allowing you to attach the next instruction directly to the end of the previous one. Now, the second piece of this is bringing in the transaction data. You call the join method on your filtered customer data frame. You pass the transaction data frame as the first argument, then you specify the condition for the join, such as matching the customer ID column from both datasets. You can also define the type of join, like an inner or left join. The logic reads sequentially. You filter, you select, and you join. Here's the key insight. As Python reads this chain of methods, Snowpark doesn't touch the actual data. Transformations are evaluated lazily. The data frame simply acts as a blueprint. It records every filter, select, and join you request, but it doesn't execute them step by step. This delayed execution allows the framework to look at your entire sequence of operations and optimize it before anything actually runs. The execution only triggers when you finally request a concrete result. This requires calling an action method. If you want to print a small sample of the data to your terminal, you call the show method. If you want to download the fully processed results back into your local Python memory, you call the collect method. The moment you call collect, Snowpark translates your blueprint into a single, efficient SQL query and sends it to Snowflake. You get the benefit of writing step-by-step readable Python while the database engine still processes the data in one highly optimized pass. That's your lot for this one. Catch you next time.